Good day everyone. The title of the experiment that will be discussed today is Estimation of Heat Capacity and Entropy. My group members are Antasha, Anissa, Raiden and myself Pavitra. Without further ado, I'll start off with the summary part. For the summary part, this experiment is carried out to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. In the discussion part, the estimated heat capacity with literature or existing data were compared and a bar chart of heat capacity was plotted. The following were discussed in the discussion part. First, the total entropy generated during the above process. Second, the sources of errors and methods to minimize the errors. Third, justification of the importance of stirring the water in the container. And finally, the justification on the importance of transferring the hot metal quickly into the water. From the experiment, the value of specific heat capacity for copper, aluminium and iron is 0.52958 kJ per kilogram Kelvin, 1.35633 kJ per kilogram Kelvin, and 0.64496 kJ kilogram per Kelvin respectively. Then a bar chart was generated to compare the heat capacity of the three different metals. The total entropy generated for copper, aluminium and iron is 0.0008 kJ Kelvin, 0.00069 kJ Kelvin and 0.00091 kJ per Kelvin respectively. The heat capacity value obtained is then compared with the theoretical value, and ways to minimize the errors during the experiment is to be found.
Okay, as an introduction, the main objective of this experiment, estimation of heat capacity and entropy generation, open-ended experiment, is to estimate the heat capacity of different metals and to estimate the entropy generated when these metals are dropped in a container containing water. In this experiment, we placed the metal that had been weighed before the experiment began inside the beaker of hot water that being heated by a hot plate and wait till it reached certain amount of temperature. Then, put the metal immediately into the cold water and record the temperature. So for this experiment, we can determine the heat capacity and the entropy generation of copper, aluminium and alloy. Thank you. Assalamualaikum and hi everyone, I'm Anissa. As for the theory part, heat capacity is mainly known as the quantity of heat energy required to raise the temperature of a body by a certain amount. In SI units, heat capacity, the symbol of C, is the quantity of heat in joules required to increase the temperature of 1 Kelvin. To get more understanding about what heat capacity is about, as for example, there are two bodies of differing temperatures exchange heat. The amount of heat lost by the warmer body equals the amount of heat absorbed by the cooler body, and an intermediate equilibrium temperature is attained. So, theoretically, no heat is lost to the surrounding. How it can be happened? The presence of hydrogen bonds affect a material's heat capacity. The intermolecular forces make it more difficult to increase the kinetic energy and thus temperature of a material. The formula is given by heat lost by the solid is equal to the mCp multiplied with T2 solid minus T1 solid. And heat gained by water is equal to M2 multiplied with Cp and multiplied with T2 water minus T1 water. Cp water is equal to 4.187 kJ per kilogram Kelvin. So at equilibrium phase, T2 solid is equal to T1 solid. At equilibrium, T2 solid is equal to T2 water. In addition, the change in the state of disorder of a thermodynamic system that is associated with the conversion of heat or enthalpy into work is known as entropy change. A system with a great degree of disorderliness has more entropy. Entropy generation, or called as entropy production, is the amount of entropy being produced in any reversible process. The entropy generated during this process is determined from these formulas. The change of S equal to mCp ln T2 over T1. And the change of S total is equal to the change of S metal plus the change of S water.
Okay, so hello, my name is Siti Natasha binti Suhaimi. So today I'll be explaining to you about the methodology for this experiment. So the first thing first, we have to talk about the apparatus. The apparatus involves our metal string, thermometer, aluminium foil, three different metals which is copper, aluminium and iron, beakers, water, hot plate and weighing scale. So for the methodology, the first step is the copper metal was weighed by using weighing scale and was recorded in table 1. This step was repeated for aluminium, copper and iron. Okay, so the second step is 100 ml of water was poured into the first beaker. Okay, so for the third step, then the water was heated on the hot plate. Then the copper was attached with a metal spring and was lowered inside the heated water until fully submerged. The copper was allowed inside the water until 80 degrees Celsius temperature was reached. The fifth step is 100 ml of water was filled in the second beaker and the initial temperature of water was measured by the thermometer. So and then for the sixth step, the temperature for the first beaker was measured. Then the copper block was taken out from the first beaker and was immediately transferred to the second beaker using a metal string. And the last, the eighth step, the beaker was covered by aluminium foil to minimize heat loss. So for the second last step, the temperature of the water was recorded for every time interval in table 1 until constant temperature. The water was stirred continuously throughout the process to ensure the heat distribution. Okay, so for the last step, repeat the experiment from step 1 until step 9 for aluminium and iron metals. Okay, that's all from me. Thank you.
I'm Radhan from Group 5. So today I will explain about the results and discussion part for experiment 7, which is the estimation of heat capacity and entropy generation. So let's start with the results part. For the results part, the mass of water given was 0.1 kilogram and the heat capacity of water at 25 degrees Celsius given as 4.187 kilojoule per kilogram dot K, and the initial temperature of metal T solid was given as 80 degrees Celsius. Three metals were used: copper, aluminium and iron, and the mass of copper was 0.1153 kilogram, the mass of aluminium was 0.0378 kilogram, and for iron it was 0.1105 kilogram. And the time taken for the metal to reach its equilibrium temperature was recorded, and for copper it was 32 degrees Celsius, and for aluminium it was 31 degrees Celsius, and for iron it was 33 degrees Celsius. So we have to calculate the heat capacity of metal at 25 degrees Celsius, and we have to calculate the entropy change of metal, entropy change of water and total entropy generated. So to this, we take example for copper. We have to calculate the heat gain of water first. So the heat gain of water, the formula is mass times with the heat capacity of water and times with the change in the temperature. So heat gain water is equals to mass of water 0.1 times with the heat capacity 4.187 and times with the change in temperature 305 Kelvin minus 298 Kelvin, and we will get 2.9309 kilojoule. So from this we can calculate the heat capacity of copper using the same formula, and where we will get the heat capacity of copper is equals to 0.52958 kilojoule per kilogram dot Kelvin. So from here we can calculate the entropy of copper using the formula as equals to mass times with the heat capacity times with the ln bracket temperature 2 divided by temperature 1. So here the temperature 2 is 305 Kelvin and for the temperature 1 is 353 Kelvin, and using the formula we will get the entropy of copper is equals to negative 0.00892 kilojoule per kilogram. And finally we have to calculate the entropy of water using the same formula as equals to mass times heat capacity times with the ln temperature 2 divided by temperature 1. So we will get 0.00972 kilojoule per kilogram. The total entropy as total is equals to total entropy of water plus with the total entropy of metal. So we will get the total for copper is equals to 0.0008 kilojoule per kilogram. and the calculation were repeated for all aluminium and iron as well. Moving on to the next part, which is the discussion part. So the first discussion is comparison of experimental value and theoretical value for specific heat capacity. So for the experimental value of specific heat capacity of copper was 0.52958, for aluminium it was 1.35633, and for iron it was 0.64496. For the theoretical value of specific heat capacity of copper was 0.385, for aluminium it was 0.9, and for iron it was 0.444. So the percentage of error was calculated, where the theoretical value minus with experimental value over theoretical value and times with 100%. So for copper it was 37.55%, for aluminium it was 50.70%, and for iron it was 45.26%. So from here we can see that the heat capacity obtained in this experiment slightly different from the theoretical heat capacity, and one bar chart was plotted where it is clearly shown that the aluminium has the highest heat capacity. So the next discussion is total entropy generated during the process. So the second law states that there exists a useful state variable called entropy. The change in entropy, which is delta S, is equal to the heat transfer, which is delta Q, divided with the temperature T. The second law states that if the physical process is irreversible, the entropy of the system and the environment must increase. The final entropy must be greater than the initial entropy. When a hot object comes into contact with a cold object, this is an example of an irreversible process. They eventually reach the same equilibrium temperature. When the objects are separated, they do not return to their previous temperatures. It is impossible to reverse the process of getting them to the same temperature. In this experiment, the entropy gain from copper, aluminium and iron was 0.0008, 0.00069 and 0.00091 respectively. For the third discussion is sources of error and method to minimize the error. So in this experiment, there were few errors occurred while conducting the experiment, and there are some precautions that we can take to minimize the errors. So one of the errors is the beaker is not being fully insulated. This will cause some heat to loss to the environment. This error could be overcome by making sure that the insulation of the beaker is done correctly. Next, the thermometer was touching the bottom and the sides of the beaker when taking the reading and while stirring the water. This difficulty could be mitigated by taking the reading carefully and using a large beaker. Finally, the parallax error occurs when taking the reading where the eyes is not perpendicular with the segregation mark of the apparatus. It can be minimized by making sure that the eyes are perpendicular with the scale of apparatus when taking the readings. The next discussion is importance of stirring the water in the container. Stirring the water in the container is important because it allows the heat emitted by the metals to be evenly distributed throughout the water. As a result, the water's temperature rise is consistent. The last discussion is the importance of transfer the hot metal quickly into the water. The importance of transferring the metal quickly into the water is so that the heat loss to the surrounding could be minimized and reduced as much as possible. Heat is naturally transmitted from a higher temperature to a lower temperature since the surrounding temperature is significantly lower than the temperature of metal. As a result, if the metal is not immediately moved into the water, the precise equilibrium temperature cannot be achieved since some of the heat is transmitted to the environment.
In conclusion, the heat capacity of different metals provided and the entropy generated was obtained. The experimental value for specific heat capacity for copper, aluminium and iron is 0.52958 kJ per kilogram Kelvin, 1.35633 kJ per kilogram Kelvin, and also 0.64496 kJ per kilogram Kelvin respectively. Aluminium has the highest experimental specific heat capacity and the copper has the lowest specific heat capacity. The percentage error that we gained when comparing the specific heat capacity in this experiment with the theoretical value is 37.5% for copper, 50.7% for aluminium, and 45.26% for iron. The percentage error that we gain is probably due to some errors that have been made during the experiment. The total entropy generated for copper, aluminium and iron is 0.0008 kilojoule Kelvin, 0.00069 kilojoule Kelvin, and also 0.00091 kilojoule per Kelvin respectively. The value of entropy generated is higher than 0, proving that this is an irreversible process.